When compound events are connected with the word or, we use the addition rule. You'll first need to decide if you are working with a mutually exclusive or not mutually exclusive set of events. If they're mutually exclusive, then the probability of event A or B will be equal to the probability of event A plus the probability of event B. So the addition sign acts as the or statement connecting the two compound events. When you're working with not mutually exclusive events, your formula starts off the same, but you have to get rid of that overlap. So if you look at your Venn diagram where we have the probability of the kitten and the probability that you're orange, you've already accounted for the probability of the first event. Now you've added the probability of the second event. So you've duplicated a portion where you are both a kitten and you're also orange. So you need to subtract off where that duplication occurs. That's the probability of A and B occurring. So the probability of both is the portion you need to subtract off for not mutually exclusive events. So let's see how we're going to apply the not mutually exclusive or the mutually exclusive formulas with the addition rule. So here we have the first example where we want to find the probability of selecting a heart or you're rolling a 6 on a die. When you're trying to determine what type of exclusivity you have, think about you have a deck of cards on one side and a die on the other. So if you throw the die on the ground, doesn't matter what happens to that die, going and choosing a card out of a deck of cards doesn't matter or doesn't affect what happens with the other. So these are two mutually exclusive events. To find the probability of selecting a heart in a standard deck of cards, I have 52 cards in a deck, and now I have 13 of those cards are hearts. So 13 out of 52 will be my probability of selecting a heart. Plus, on a 6-sided die, there's only 1 6, so 1/6 is my probability of selecting or rolling a 6. Putting that into my calculator, I get 0.4167. For this next example, I want to find the probability of selecting a king or a diamond in a standard deck of cards. Now the issue becomes I'm working with the standard deck for both. So if I think about what's happening and I'm looking at my deck of cards, if I pull a card, it can be a diamond, and if I pull a card, it could be a king. This means that they're not mutually exclusive. It is possible that there could be some overlap where I could get a king that is also a diamond on their card. So when I'm looking to find the probability of selecting a king or a diamond card, I'm first going to think about the probability of selecting a king. So there's 4 cards that are kings out of the entire deck of 52. And then I need to look at how many diamonds there are. And so since diamonds are one of the 4 suits, I have 13 out of 52 of those. I then need to think about any of the overlaps of when there is both a diamond and a king. And that's one way to always think about it, is if you change the word or to the word and. When am I a king and a diamond? There's only one of the 52 cards where you're both a king and a diamond. So I'm going to need to subtract off that duplicate card. Putting those fractions into my calculator, I get 0.3077 as my probability. In this other example, we are looking at a study where women were asked if they like chocolate as a gift or if they prefer flowers. And so your options were to pick those, or you could also just say, hey, I like both. And so if you notice, if you add up all these percentages, you're going to get over 100%. And that is because you have an overlap where people were allowed to choose not just one or the other, but they could choose both. So we want to find out what the probability of selecting a woman who likes chocolate or flowers. When you're given information as a percentage, you need to remember to turn those into decimals when you're putting them into your formulas. So we end up setting this up as the 0.38 plus 0.61 minus the 0.12. And in your calculator, you're going to see 0.87, but you need to add 2 additional zeros so that way you have the 4 places to the right of the decimal for your rounding rule.